Good day, everyone. On behalf of Quality Support Group QSG, I'd like to welcome you to today's webinar, Leadership Principles of Dr. W. Edwards Deming, presented to you by Jim Leonard. QSG is committed to providing up-to-date, useful, and credible information on the topics that you care about. Thank you for taking the time to join us today. I hope everyone is safe and doing well under these difficult times, and we hope that we can get through this time and get back to normal operations as soon as possible, but in a safe manner. My name is Angelo Skangas, and I'll be the moderator for today's webinar. A few things before we get started. Today's webinar will be approximately 60 minutes in length. Jim will make a presentation for about 45 minutes, 50 minutes, and then we'll have a question and answer session. We welcome your questions, and please use the chat box on the top right-hand corner of your screen to ask questions throughout the presentation. Once Jim has completed the presentation, I will ask those questions, and we can have a conversation around the questions that you have. Everyone should have received a PDF document of the presentation, and you can follow along as Jim presents. It was an attachment to the invite. If you do not have a presentation, you can email Chris at qualitysupportgroup.com right now, and he'll send you a copy. To make this webinar as effective and efficient as possible, we ask you to please mute your line and also turn off your video. We have found out that everybody streaming these days from homes has created a little bit of stress on the Wi-Fi systems, and we want to make sure we don't have any issues. So please mute your line and turn off your video camera. And I think that's it in terms of any prerequisites. Now I'd like to introduce you to Jim Leonard. Jim is a consultant and educator who specializes in teaching the principles of the late Dr. W. Edwards Deming as a new system of management. Jim has worked in manufacturing and service organizations throughout North America, Europe, and China. He serves as a senior consultant for Quality Support Group in Westford, Massachusetts. For 29 years, Jim presented his seminars at the Division of Corporate and Professional Education at Worcester Polytechnic Institute in Worcester, Massachusetts, where he also served as an adjunct professor in graduate operations and industrial engineering. Jim currently works with clients in other countries as well, in China and other countries around the world, and also as an instructor on the China Institute for Innovation in Shanghai. Jim is an alumnus of U.S. Naval Academy, where he majored in mechanical engineering and analytical management, as well as the George Washington University and Clark University. Jim currently resides in Ave Maria in Florida with his wife, Kate. They are the proud parents of 6 children and the grandparents of 10 grandchildren. Jim, thank you very much for taking the time. I'll turn it over to you.
Okay, thank you, Angelo. One slight correction, if people were wondering, we're actually scheduled for 90 minutes. When Angelo said 60, I thought, wow, I'm going to have to talk fast. So
sorry about that, Jim.
That's all right. So to Angelo's words of welcome, I'll add my words of thanks. Thank you for investing this time with us. I was working for a company about 40 years ago. My wife's getting old. And we started to incur the pain of trying to implement a continuous improvement process, an organization excellence process. And because of my position there, I was called upon to teach seminars on statistical theory, concepts, methods, throughout that company of 17 divisions in 5 states and 3 foreign countries. And very early on in that experience, I got into a shtick of opening workshops asking people, well, what are your major concerns? What do you want to make sure we address? What topics do you want to make sure we address before we wrap up? What are the things that drive you nuts? And it was interesting. union, non-union, foreign, domestic, components manufacturing, R&D, batch processes. The responses were very similar. The concerns were very similar. Among them, product development lead times take too long, lack of data, excessive lead times, late shipments, poor communication, field failures, high turnover, vendor quality and delivery performance, low yields, customer complaints, customer returns, and on and on and on. And now, today, in my work with quality support group clients, I still open my workshops with the same question. You know, what are your major concerns? What do you want to make sure we address? What are the things that drive you nuts? A recent workshop, among the responses, product development lead times take too long, lack of data, excessive lead times and late shipment, poor communication, field failures, high turnover, vendor quality and delivery performance, low yield, customer complaints, returns, etc. Concerns have not changed. For decades, despite decades of efforts throughout American management focused on improvement, I might add, successful efforts focused on improvement, the same concerns remain. And that's why I've always worked as a premise with people following the lead of Dr. Deming. We don't need any more improvement. We've worked enough on improvement. Dr. Deming noted there's a need for transformation in Western management. And transformation implies a complete change in state. We want to get to a state where we no longer have these concerns. We'll have other concerns, but we no longer want to have these concerns that just seem to keep cropping up, workshop after workshop, project after project, budget period after budget period. We no longer have these concerns. And our focus here in this 90-mile-an-hour, barely scratching the surface webinar is on the key elements of this transformation process based on Dr. Deming's teaching and principles. First key element, we adopt a systems perspective. Dr. Deming referred to it as appreciation for a system, striving for optimization. It's all rooted in the science of physics. Striving for components of our company's engine that work well together. Not striving for perfect individual sales, marketing, design, development, operations, QA, HR, finance, purchasing, and other individual departmental components versus individual departmental goals, objectives, and standards. Second key element of the transformation process, we apply statistical method to continuously learn about and improve our systems. And the third key element of the transformation process, our focus here this morning, is the hard part. It's the part that takes too long because it takes too long. Leadership. To create, to provide, to maintain, and to continually strengthen a healthy environment for work, for learning, and for continuous improvement. And that's the hard part. That's the part that takes too long because it takes too long. That's the reason the vast majority of so-called Six Sigma initiatives in the United States have been abject failures. Because we're certifying green belts and we're certifying black belts and we're doing DMAIC projects and we're using software, but nobody's paying attention to the hard part. Nobody's paying attention to leadership. And in my work, what I've always presented as a model of that healthy work environment are the 14 points for management that were developed and taught by Dr. Deming. He was credited with Japan's emergence as a world economic power in the 1960s. So he was a man credited with Ford Motor Company's survival in the 1980s. But I've always presented his 14 points just as a generic model. God did not carve them into stone tablets. It's a generic model of that healthy work environment upon which you and your coworkers have to cast your unique organization's flesh. And at the foundation of that 14-point model of the healthy work environment, at the foundation of all of Dr. Deming's leadership principles, is something he referred to as the system of profound knowledge. That handout that Angelo mentioned earlier, the second half of it is a short paper by Dr. Deming, just summarizing the system of profound knowledge. And I was so thrilled when he gave it to me 30 years ago. It was 1990. Not only because he gave me permission to share it with my customers, not only because his estate later gave me permission to publish it as an appendix in my own text, but even more so because of the first sentence of the second paragraph of that paper, which reads, and I quote, "One need not be eminent in any part of profound knowledge in order to understand it as a system and to apply it." And upon reading that, I thought to myself, thank God, I'll never be eminent in any of this stuff. The system of profound knowledge, as he summarizes it in this little paper, as he expanded upon it over a period of decades in his writing and his lectures, is made up of 4 components, each of which interacts with the others. And the first component of the system of profound knowledge, appreciation for a system, striving for optimization. In 1950, Dr. Deming started a series of Saturday seminars with some Japanese executives it was all organized by Kaoru Ishikawa through his Japanese Union of Scientists and Engineers. And in the very first session, Dr. Deming brought up a model of production as a system. And those in attendance, some of those in attendance later said, it was just mind-blowing to them to consider that their suppliers were an integral part of their own production process. They never looked at things that way. Suppliers were people to squeeze for lowest price. Suppliers were people to keep honest by having multiple suppliers and playing them off against each other. Suppliers were a source of gaining advantage for yourself. And suddenly, they're presented this view. No, suppliers are an integral part of your own process. And it was just a breakthrough in practice of supplier relations among those companies. Suppliers now started to be treated as valued and respected partners, as opposed to a source of lower price. When I wrote my book, everybody was writing about Deming applied to business. So I thought, hey, we had young children. Teaching and learning is a process. I wonder how this applies to K through 12 education. And I corresponded with Dr. Deming. He was so helpful and kind and patient with me. I met with him a couple of times, and we came up with kind of a restatement of this view, now looking at education as a system for skill and knowledge development. And yes, parents, families are customers of the system. And parents have a right to ask teachers, hey, what have you done for me and my children lately? But when you look at it as a system, parents, families are also suppliers. Teachers have right to ask of the parent, what have you done for me lately? What have you done for your child lately? And when you look at how this works with ongoing, never-ending research, customer research, child development research, driving ongoing, never-ending activities of design and redesign for improvement, Deming's point 5, constantly and forever improve every process. The school, the university that appreciates a system, consider the ongoing design and redesign. It would be impossible to find a teacher. It would be impossible to find a professor using the same lesson plan they used 5 years ago because of this continuous improvement energy. At the output of any and every process, there will be variation. Dr. Deming taught and wrote, variation there will always be between people, between machines, between products, between vendors. There will always be variation. The key question, he insisted, the key question is, what is that variation we're finding at the output of the process trying to tell us about the process and about the people who work therein? That's the question. And we view this variation we find at the output of processes through the lenses of the systems model of variation. Others refer to it as the Taguchi loss function, named after Dr. Genichi Taguchi, who invented it in Tokyo in 1960. But really all Taguchi brought to the systems table 60 years ago was this quadratic algebraic loss curve. And in your little paper of Deming's, he notes that because the loss curve is a parabola, we need not achieve perfection. We need not achieve some precise optimal. A little bit of variation, one way or the other from optimal, any loss would be imperceptible. But the same model also illustrates, as variation increases, loss increases ultimately exponentially. So how does this guide the leader who appreciates a system? Variation is the enemy because it will always introduce loss. That loss may be staggering. I may have had to scrap an entire production run. That loss may be imperceptible and unmeasurable. But the way I urge leaders to share this with people is to point out our product is already good or bad by the time we test a product. The test adds no value. The product's already good or bad. The enemy is the variation and sources of variation swirling in and around the design and manufacturing processes. Deliveries of product or service to customers are already on time or late upon delivery. The enemy is the variation and sources of variation and delays swirling in and around our manufacturing, test, packaging, and distribution processes. Variation is the enemy. Therefore, appreciating a system, variation is the enemy, we must come up with new definitions. Quality can no longer be defined as mere compliance or conformance to specification or standard. Quality is minimal variation around some target or optimum value. Deming's point 6, institutionalized training. Deming's point 13, adopt a vigorous program of education and self-improvement for everyone. Well, how is the leader going to know, how is this training working? Are these methods helping? Are they making things better? What is our definition of quality improvement? Reduced variation over time around some target or optimum value. It brings to mind something Peter Drucker wrote many years ago. Management's job is to accomplish the monthly abandonment of waste, the monthly reduction of waste, the monthly reduction of variation. If at the end of any given month, the manager is unable to show documented evidence of having accomplished reduced variation in one of his or her processes, then he or she has not done their job. The monthly abandonment of waste. And leadership must provide a healthy work environment in which individual employees and groups are continually seeking and taking action on answer to these questions. Question number 1, who are my customers? Who uses what I produce? Who uses what I pass on? Question number 2, what are their needs? Not their hopes and wishes, what are their needs? Question number 3, how can we best meet those needs showing minimal variation, because variation is the enemy? And continuous improvement is measured by reduced variation over time, because variation is the enemy. How are we doing? What can we do better? And the leader, appreciating a system, directs those seeking answer to the question, what can we do better in here, inside the pipe, inside the process? A physicist named Walter Shewhart at Bell Laboratories came up with this concept many years ago. His concept being most of the problems, most of the failures, most of the variation, waste, cost, loss that you find at the output of any and every process, most of it was produced by the process itself. Made up of what Dr. Deming later labeled common causes of problems, failures, variation, waste, cost, loss from within the process. And intuitively, intellectually, when people first look at this, they're going to say, well, that's obvious. We can have the best trained, hardest working people in the world working in production. If we get garbage raw materials in from a supplier, what's going to come out of our production pipe this week? Garbage. It's so obvious. And yet, despite the intuitively obvious nature of this model, the leader has months of work ahead of him or her to help people to think this way, to get this holistic model of the process to pop into people's minds whenever we say the word quality or whenever we say the word problem. Because we have experienced, we have been conditioned, we have come to accept a completely different model. I like to call it the process model from the age of mythology, and there it is, person equals output. And we need not go into the intermediate analytic statistical theory Walter Shewhart invented, upon which he built his rational model. Draw upon your own experience. Think of your own personal work career, beginning with your first part-time job in high school. Have you ever had an immediate supervisor whose first question, when he or she has first encountered a problem, has been, who's responsible? Give me a name. Did you ever work for that person? If yes, welcome to the age of mythology. Did you ever work for a company that had one of these sorry, self-esteem destroying, mediocrity-inducing practices of annual appraisal of performance? If yes, welcome to the age of mythology. I had a call some time ago from a quality director at a QSG client, Six Sigma Black Belt, and he said, Jim, would like you to come in and help us to derive some new KPIs for performance, KPIs, key performance indicators, key measures. I said, oh yeah, sounds great. What process? He said, no, not process, people. He said, we want to implement Six Sigma into our performance management system. That's what they call the performance appraisal system. I said, sounds great, can't be done. He said, oh, no, we've already done it with one group and we want you to help us to do it with other employee groups. I said, well, what group have you done it with? He said, software development engineers. I said, oh, that's interesting. What's the KPI? What's the key measure? He said, project performance versus schedule. He said, this is a very important key measure and it's easy to get the data. I asked him, on the average, how long does it take to get a change request approved in your company? And the black belt said, what? I said, well, I'm a software development engineer. My project requires a change to a validated test process. I submit the change request. On the average, how long does my project schedule slip awaiting approval? The black belt had no earthly idea, hadn't even thought about it. I said, look, you want better development engineer performance of schedule? Fix your darn change management process. We're sick and tired of sending change requests off into the black hole of the change management bureaucracy, not knowing if it's going to get walked through to approval today, or if my project schedule is going to slip 3 weeks awaiting approval. And the tools we apply to learn about these processes. See, people can perform no better than the process allows. Dr. Deming's point was stop appraising people and start leading people. Lead them back up inside the process pipe, study the process, change the process, improve the process. Every time you improve a process, the performance of every person who works in that process can improve. In the absence of process improvement, people can perform no better than the process allows. And the tools we apply to learn about these processes, the tools we apply to continuously improve these processes are the essential statistical methods, second key element of the transformation process. And if we agree that variation is the enemy, the science of variation we encounter in the intermediate statistics, second component of the system of profound knowledge, some knowledge of the theory of variation. And Deming was such a wordsmith. I love how he worded this. Some knowledge of theory of variation. We need not be eminent. We need not be expert. We need not have a PhD in statistics. Some knowledge of the theory of variation with great emphasis placed upon understanding and differentiating between common cause variation from within the process or system. Common causes produce outcomes that are different, but they're not significantly different, and special cause variation from outside the process or system. Special causes produce outcomes that are not different, they're significantly different. So if we agree that variation is the enemy, first the leader must seek to determine what type of variation am I up against? Because different types of variation require completely different types of corrective action. So let's go back to the 1920s. Let's go visit Bell Laboratories. Let's go meet a physicist named Walter Shewhart, who back then first took a stab at defining two very different types of variation one may encounter at the output of a process. The first type of variation he operationally defined, he labeled it controlled variation. He wrote, this type of variation is random. This type of variation is mathematically predictable. But upon that declaration, heads throughout the world of enumerative statistics imploded. Wait a minute, Professor Shewhart. If something's random, how can you expect us to predict it? If you claim that something's predictable, how can you turn around and label it random? People just didn't get it. It didn't fit the confines of the enumerative, descriptive, Z-table laden statistics. He was pushing the envelope. He was inventing analytic statistics. And a very simple illustration of this phenomenon the leader can use to help people wrap their heads around this will be found in the process of rolling dice. When we roll a pair of dice, we can mathematically predict that dice roll is going to come out somewhere between a 2 and a 12 inclusive. Though the individual outcome of any one dice roll will be at random within those predictable limits. Over a series of dice rolls, we learn, there's only one combination on the dice. It'll give me snake eyes, 1-1. But there are 6 combinations on any roll of the dice to give me a 7. 1-2, 1-6, 2-5, 3-4, 4-3, 5-2, 6-1. So over a series of dice rolls, we can mathematically predict we're going to roll a 7 6 times more often than a 2 or a 12, though the individual outcome of any one dice roll will be at random within those predictable limits, given those predictable probabilities. Therefore, Shewhart concluded this type of variation is due to random chance. Roll the dice. That characteristic is going to come out between here and here at random. Roll the dice. Your process is stupid. It doesn't know and it doesn't care what your specs, standards, goals, hopes, or wishes might be. It's going to give you whatever it's capable of giving you at random. Roll the dice. But a second type of variation Shewhart defined. He labeled it uncontrolled variation. He said this type of variation is non-random. Therefore, this type of variation is not mathematically predictable. If we were to roll a pair of dice and get a 13, that's goofy. There's no way we could mathematically predict when some fly was going to come along and drop a miscellaneous dot on one of our sixes at the same time that 1 in 36 random chance of rolling 2 6s came into play. That's goofy. Therefore, Shewhart concluded, this type of variation is due to some assignable cause. You can put your finger on the assignable cause of that outcome. Controlled variation, you can't put your finger on it. It's random chance. In the mid-30s, Dr. Deming added to Shewart's core theory of variation when he connected the dots. He connected the dots between the core theory of variation and concept of a process. So beginning in the mid-30s, Dr. Deming started to refer to controlled variation as common cause variation. He agreed with his mentor, Walter Shewhart. Common cause variation is controlled, random, mathematically predictable due to random chance. He added the phrase and concept. It is due to common causes of variation from within the process or system. Therefore, if we determine through analysis of key measures for a given process that those evaluative data plot in a random pattern, that's the key, a random pattern, we gain knowledge. This is the source of the enemy. This is the source of the variation. This is the source of the problem. This is the source of the failure. All of those outcomes, high and low, good and bad, in and out of spec, on time and late, came out of exactly the same process pipe. Therefore, if we are not pleased with any one of these discrete outcomes, our corrective strategy is and must be change the pipe. We've got to change the process that produced that failure. If we do not change the process that produced that failure, we will forever suffer that failure in the future at random. Roll the process dice. More specifically, one strategy. Process issues by their very nature cut across different groups, functions, and departments. So with much malice aforethought, we select representatives from those different groups, functions, and departments, and we sit them down at one table. And we give that cross-functional, multidisciplined process improvement project team the time, the training, the tools, the direction. Get back up inside that process pipe, study the process, come back to us with your recommendations, plural, backed up by data, for changes, plural, we can make to the process to improve its future output. They must bring recommendations, plural. We must make changes, plural, because the source of the problem is common causes, plural. A higher order strategy for dealing with common cause variation, DOE, design of experiments. So Ronald Fisher invented factorial designed experiments back in the 20s for controlled variation because DOE empowers us to include multiple variables in our experiments and tests. No more scientific method, no more one factor at a time, no more OFAD. Hello, we're not in Sister Carmela's high school chemistry class anymore. We must include multiple variables in our tests because we're up against the effects of multiple causes of variation. Connecting the dots between the core theory of variation and concept of a process in the mid-30s, Dr. Deming started to refer to uncontrolled variation as special cause variation. Once again, he agreed with his mentor, Walter Shewhart. Special cause variation is uncontrolled, non-random, not mathematically predictable due to some assignable cause. He added the phrase due to some special cause of variation from outside the process or system. Therefore, if we determine through analysis of our key measures that those evaluative data plot in a non-random pattern, that's the key, non-random pattern, we gain knowledge, the source of the enemy, the source of the problem, the source of the failure is some special cause of variation from outside the process, and no amount of work on my process will address it. In the face of special cause variation, guided by some knowledge of theory of variation, the leader directs a completely different corrective strategy. We're not going to work on the process. Don't design an experiment with process variables represented. The process didn't do it. We're going to take out a rifle. We're going to aim at that failure of that unit, assembled by that operator using that batch of vendor components, tested by that analytical instrument, and we must take special action to find, remove, and prevent the reoccurrence of that special cause. Because if we do not find, remove, and prevent the reoccurrence of a special cause, it's going to come screaming in without warning in the future, unpredictable by its very nature, and mess up any of our efforts to improve the process. More specifically, our strategy in the face of special cause variation, QSG's systematic root cause analysis methodology: name the problem, describe the problem, list possible causes, test possible causes, identify most likely cause, singular, verify true cause, singular, because we're out after a smoke and gun root special cause, singular. And that's the theory, the knowledge of which must guide the leader in his or her decisions and actions and plans. Common cause variation. Don't ever let somebody get away with coming in and claiming there's some silver bullet fix to a process problem, because there isn't. And Dr. Deming insisted this knowledge is essential. Absent the ability to understand and differentiate between these two very different types of variation, we will poise ourselves to commit very costly mistakes. These are noted and summarized in the little paper you can download, a Deming System of Profound Knowledge paper. Deming's mistake 1, to treat as a special cause from outside the process any problem or failure or breakdown that in fact was the result of common causes from within the process. This leads to tampering, not process improvement. Deming's mistake 2, to attribute to common causes of variation, in other words, to blame the process for a problem, failure, breakdown, that in fact was the result of some special cause from outside the process. The process didn't do it. Classic example of Deming's mistake 2. Again, what is Deming's mistake 2? We're investing corrective action, time, energy, and resources into the process when the process didn't do it. It was the result of some special cause from outside the process. Let's say, one of you is manufacturing companies. Let's say that your yield losses explode. You have not an increase, you have a significant increase in rejects. In fact, the special cause was a bum batch of highly, abnormally contaminated material going into one of your suppliers from one of their suppliers. But local management reacts to those yield losses as though our production process did it, and local management invests capital in new machines and tooling. Local management just made a very costly mistake. Local management just flushed that capital investment right down the toilet. Because the special cause from the supplier to our supplier, if not found, removed, and prevented in the future, will come screaming in without warning in the future, unpredictable by its very nature, and mess up those new capital equipment and tooling just as it did the old capital equipment and tooling, and we flushed that capital investment right down the toilet. And this waste of capital, billions of dollars of misspent capital, is because our business schools do not teach rational theory of variation. Deming's mistake 1, tampering. How can we help people consider, wrap their brains around that one? Well, in manufacturing or even in an analytical lab, we have set points. We have set points: time, temperature, pressure, thickness, whatever it might be, caliper. Well, variation will always be. So around that set point, we're going to find variation. Well, out comes a roving QA inspector, pulls a sample off the line, takes it back to the lab and tests it. Doink. Hey, what are you doing? You're off set point. What does the operator do in this case? What has she been trained to do? What does the SOP require the operator to do in this case? Well, make the adjustment, reset the machine, get that thing centered. But in resetting the machine, the operator does not move just that one discrete sample. He or she shifts the entire distribution by that distance. Out comes a roving QA inspector an hour later, pulls another sample off the line. Doink, what the heck are you doing? You're way off set point. What does the operator do? What has he usually been trained to do? What's SOP required the operator to do? Make the adjustment. Get that thing centered. But in making the adjustment, the operator doesn't move just that one discrete sample the QA tech pulled. He or she shifts the entire distribution by that distance. What has the operator done to the variation we started with? Obviously, they've increased it. What happens every time we increase variation? We increase loss. There are operators throughout our production system trying their best, making things worse. Trying their best, making things worse. Because some engineer who lacked knowledge of theory of variation built that over control, tampering, variation, waste, cost, loss increasing scheme into the SOP during process validation that the supervisors are using to train the operators. These are very costly mistakes. Outside of manufacturing, many, I won't say all, but many budget and forecast updates are tampering. Give me 30 minutes with your accounting and marketing people. I'll prove it. Because we have a 3-month forecasting period. At the end of the first month, whatever happened that month, we treat as an absolute, and we we update. And then at the end of the next month, whatever happens then, we treat as an absolute, and we we update. And then there are people out in operations trying to play badminton in a windstorm. You probably won't believe this, but I've actually worked with clients over the years that will have 2 to 3 changes to production schedule per week. Per week. Those operations people are my heroes. How do you manage inventory? How do you manage labor when your target moves 2 or 3 times per week? This is tampering. And the cost is devastating. But the leader must also bear in mind these costly mistakes are also going to have an effect on the human component of the system. It is not merely over adjustment around machine set point. For example, when we form teams, project teams, work teams, those teams must be managed. But there's a difference between managing and tampering. Deming's mistake 1. I was working with a client's research center over in England many years ago, and one of their PhD biochemists came up to me with something that he found that a gentleman had written, and he thought it was interesting, and I took a copy. This gentleman had written, "We trained hard, but it seemed that every time we were beginning to form up into teams, we would be reorganized." I was learned later in life that we tend to meet any new situation by reorganizing. And a wonderful new method it can be for creating the illusion of progress while producing confusion, inefficiency, and demoralization. Have any of you ever worked for one of these companies, go through these constant reorgs, and you had to keep your business card in erasable type because you didn't know what your department title was going to be next week? I was in a large electronics manufacturer, semiconductor, and I asked one of the engineers who were in the workshop, I said, "Who's your boss?" He didn't know. They had just gone through a reorg. He didn't know who he reported to. I said, "Well, gee, when are you going to find out?" He said, "I don't know. I guess my next review, whoever gives it to me must be my boss." This observation was recorded in the field journal, the biochemist told me, in the field journal of a Roman centurion named Gaius Petronius in 66 AD. And the more I come across stuff like this in my work, the more I am by how the more things change in Western management, the more they stay the same. Here's a guy almost 2,000 years ago recording in his field journal his observation of the confusion, inefficiency, and demoralization among his troops, driven by these constant, often political reorgs within the Roman legions. And in my work today, I meet people every week who suffer the same confusion, inefficiency, and demoralization. That's tampering, Deming's mistake 1. That is its effect on the human component of the system. This is not merely mechanical over adjustments around machine set points. Now, however, we encounter a dilemma. The human brain is incapable by eye or feel of looking at a run chart, looking at a histogram, looking at a data set, and determining by eye or feel, where is that line of demarcation that will inform the leader where the effects of common causes of variation from within the process leave off, in which case I direct one form of corrective action, or whether it's the result of some special cause of non-random goofy variation from outside the process or system, in which case I, the leader, must direct a completely different corrective action strategy. Because if I don't, I run the risk of committing a costly mistake. We need help. The statistician needs help. We need some practical statistics. So we go to that normal curve theory. We're at approximately plus and minus 3. Standard deviation measures from the average. We will find those lines of demarcation we cannot determine by eye or feel. Those lines of demarcation that inform us where the effects of common causes of variation from within the process or system leave off, in which case we're directing a multivariate improvement or corrective action effort. Recommendations plural, changes plural, or if it's the result of some special cause of non-random goofy variation, in which case we're directing a completely different strategy for corrective action. It is this rational theory that lets us know what type of variation we're up against. And yet, so many of our clients at Quality Support Group, despite years, if not decades of effort, are finding it so difficult to apply this rational theory in their organizations, because the normal curve is a static model. It just sits there. It doesn't even have a pulse. All of our clients work in a dynamic process, new product development, dynamic, administration, dynamic, forecasting, dynamic, assembly, dynamic. So the question becomes, how can this static model help us in our dynamic process world where things are not and never will be static? So what did Professor Shewhart do almost 100 years ago? He just flipped it on its side. He extended those upper and lower limits of controlled random common cause variation. He added the element of time and invented the statistical process control chart, an intermediate analytical tool that empowers us to apply the static model of the normal or the binomial or the Poisson distribution in a dynamic fashion. He then determined if my key measures plot in a random pattern, that's the key, random pattern clustered around the average or central line with no points falling outside the upper and lower limits of controlled, random, common cause variation. He said, I gain knowledge. In this case, the source, the process is random. What does that mean? All outcomes, though different, they're not significantly different. What does that mean? All outcomes are a result of common causes only from within the process or system. Therefore, if I am not pleased by any one of these discrete outcomes, my corrective strategy is and must be change the process. If we don't change the process that produced that non-conforming outcome, we'll forever suffer that non-conformance in the future at random, roll the process dice, multivariate. Recommendations plural, changes plural. But Shewhart also wanted to be in position real time to know if he rolled his process dice and got a 13, something special happened. He wanted beyond that evidence a special cause like a chicken on a June bug. Find it, remove it, prevent its reoccurrence. No amount of work on my process will correct that issue, he realized. That outcome, that event was not produced by my process. That was the result of some special, he called it, assignable cause of variation from outside my process. And there's a critical vocabulary term that the leader with some knowledge of theory of variation assures that everyone eventually understands, including local workforce production operators who, as we speak, may be out there tampering. They need not worry about the theory we just reviewed. They need not worry about the formulas. They need not perform the calculations. They need not conduct the stability study. But when we report this process is stable, bam, we want everyone to understand what that means. What does it mean? It means the process is in statistical control. What does that mean? Controlled variation. What does that mean? Random variation. What does that mean? All outcomes, though different, none significantly different. What does that mean? All outcomes the result of common causes only from within the process or system. Therefore, if we are not pleased with any discrete outcome from a stable process, our corrective strategy is not to make an adjustment. Anytime we make an adjustment to a stable process, we make things worse. Our corrective strategy is and must be change the process. Recommendations plural. Changes plural, because a stable process further informs us there is no special cause variation evident from outside the process or system. Was the coding on this part lower than the coding readings on all these other samples? Yes, anybody can see that. It was lower. It might have even been out of spec. It might have even been a rejected part, but it was not significantly lower. Did this student score higher on the math exam than this student? Yes, anybody can see that. He or she scored higher, but he or she did not score significantly higher. Not happy with low test scores? Get back up inside the teaching and learning process that produced that low score. Study the process, change the process, improve the process. Issuing a low grade to this child does nothing to address the process that produced that low test score. Issuing a low grade to this child destroys the child. It destroys the child. Statistical stability has to do with the source of the enemy, the source of the variation. If the process is stable, where is it coming from? Common causes of variation from within the process. If the process is not stable, where is it coming from? Some special cause of variation from outside the process. Statistical stability has to do with the source of the enemy. The source of the variation, where is it coming from? Statistical capability is different. It doesn't have to do with the source of the enemy. It's dealing with process variation. It has to do with the extent of the enemy, the extent of the random, inherent, common cause variation we observe in a process. Please note that we observe, not that we expect. We have no right to expect anything. Our processes are stupid. They don't know and they don't care what might be our specs, standards, goals, hopes, and wishes. They're going to give us whatever they're capable of giving us, take it or leave it. Management's job is to develop a sufficient number of internal resource people. Not all need be expert. 1 or 2 black belts is not sufficient. A sufficient number of internal resource people who can take these powerful, intermediate, analytic tools out into our processes and apply them. In doing so, we lean our ear against, we hear, we come to understand the voice of the process. We then turn around and compare that to the specification, standard, budget, other defined requirement to determine is the process capable. What is the capable process? Number 1, it is in statistical control. That may seem redundant, but it's not. Because remember, our literal definition of process capability is the random inherent common cause variation we observe. If a process is not stable, it is not under the influence of common cause variation, it's under the influence of special cause variation. Therefore, it has no capability. Number 1, it is in statistical control and 100% of its output. Now, we're taking some liberties here. For practical purposes, we are accepting that the average plus and minus 3 standard deviation measures defines 100% of the output, even though we know theoretically and in reality, we already know the curve runs on for infinity. We already know that. But for practical purposes, 100% of the output is defined by the average plus and minus 3 standard deviation measures. All meets quality requirements, then we have a capable process. And there is that CPK, that process capability index calculation we use to put a number on this picture. It's a number, it's an index, it's a ratio that compares the variation that's allowed, as shown in this case by the specification limit, to the variation that exists as dictated by our stupid process's capability that doesn't know and doesn't care what the spec might be. We divide that variation that's allowed by that variation that exists, and anything that goes up is good. The higher this index, the larger the ratio, the more capable the process. And the CPK calculation, again, compute for stable processes only. If the process is not stable, none of this applies. But to come up with that, first we measure this distance A from the average process output to the upper spec limit, or for comparison to lower spec, to the lower spec limit. That distance A defines the variation that's allowed, as defined in this case by the specification limits. Next, we measure this distance B from the average process output to plus 3 standard deviation measures, the upper process limit, not the upper control limit on the X bar chart, the upper process limit, or for comparison to lower spec, minus 3 standard deviation measures. That distance B defines the variation that exists as dictated by our stupid process's capability that doesn't know and doesn't care what the spec might be. To come up with this index, we divide distance A, the variations allowed, by distance B, the variation that exists. And anything that goes up is good. And the most common CPK target I encounter among our clients, both for vendors and for internal operations, is a CPK of 1.33. We want to have at least 1.33. That's kind of the standard. Another way to look at this, rather than going through the derivation of the formula as I just did, let me add, by the way, what I have sketched out here is what would be referred to as a CPK sub U, the CPK compared to upper spec. This region we would calculate and call the CPK sub L, the CPK versus lower spec. And the CPK for your process is whichever one is lower. Because whichever one is lower is going to inform us of whatever spec limit we're at the greatest risk of violating. But that CPK of 1.33, why is it such a magic number? Well, if I have a CPK of 1.33, that means my process, if centered on nominal, is using only 75% of the total tolerance. My process limits are always defined by the average plus or minus 3 standard deviation measures. But if I'm using only 75% of the total tolerance, I'm going to have one more full measure of the standard deviation between my process limit and the nearest spec limit. So what does this mean? Once we release, if our standard for technology transfer is the newly developed product or process must be in a stable state with a CPK of at least 1.33. What that means is, once released to production, short term, the production process could go out of statistical control by as much as one full standard deviation measure. Local workforce personnel, local supervision, manufacturing engineers will have time to perform the root cause analysis to find, remove, and prevent the reoccurrence of the special cause without producing any bad product. Hence, in this case, the distance from my average process output to the nearest spec limit is going to be 1, 2, 3, 4 standard deviation measures, or 4 sigma capability. This is where I get a lot of kick out of working with, yeah, we're doing 6 sigma. Well, what's your CPK standard? 1.33. No, you're not. You're doing 4 sigma. But don't forget, the curve runs on for infinity. Even in a stable state with a CPK of 1.33, we're going to be producing 64 parts per million defective. How many of your customers are going to be happy with that? So if this is unacceptable, we have to go to work. We apply, now we probably have to apply design of experiments, because when we do so, we expect surprises, and we find some surprises, and we make some changes, and we're successful. We make some changes, plural, because the process was still stable. We get it down there where it's centered on nominal. We're using only 50% of the total tolerance. That gives us a CPK of 2.0. When I divide the variations allowed by half the variation that exists, it comes out 2.0. Our process limits are always defined by the average plus or minus 3 standard deviation measures. But if I'm using only 50% of total tolerance, I'm going to have another 1, 2, 3 standard deviation measures between my process limit and the nearest spec limit. Hence, in this case, the distance from my average process output to the nearest spec limit will be 1, 2, 3, 4, 5, 6 standard deviation measures, or 6 sigma capability. So when people ask me, gee, what does 6 sigma mean? Whip out a paper napkin and draw on this picture. It's a stable process output, centered on nominal, use only 50% of the total tolerance, has a CPK of 2.0. And even if it's not centered on nominal, we still have 6 standard deviation measures between our average process output and the nearest spec limit. That's 6 sigma capability. But don't forget, the curve runs on for infinity. Even in a stable state with a CPK of 2.0, we're going to be producing about 3.4 parts per million defective. Now, think about it. How many millions of centimeters of cable are there on a modern passenger airliner? Mechanical, electrical, microwave. Well, I was told there are 21 miles, so do the math. Imagine 3.4 centimeters per million are defective, subject to electrical short or fray. Thank God our aerospace industry is not settled for Six Sigma, because if they did, planes would be falling out of the sky. Whoever said Six Sigma was good enough? I think about it. I sit in empty hotel rooms. I ponder. A 1987 Ford Motor Company opened their brand spanking new automatic transmission assembly plant in Batavia, Ohio. And they built that plant around their standards at the time. Ford has good designs. Everything we produce is going to conform to good design. And it was a successful launch. They never used more than 90% of total tolerance at any design scope level. Size of the valve, size of the board, part, component, subassembly, assembly, final test. But then they ran into a problem. Ford Escorts were selling so well worldwide, this brand new plant didn't have the capacity to fuel the assembly plants. So Ford outsourced. They went to Mazda and said, hey, make these transmissions for us. So Mazda started to make Ford transmissions to Ford designs for Ford cars. Some time goes by, weird things are emerging. The repair frequency of the Batavia, Ohio parts made by Ford was 5 times higher than the Mazda parts. Test engineers from the test tracks were providing feedback. The Mazda transmission seemed to shift much more smoothly than the Batavia transmission. So they said, well, what's going on? What's going on? And they took on the classic, well-documented, there's even a YouTube video about it, Batavia study. And so some Ford engineers took a bunch of Mazda transmissions, took a bunch of Ford transmissions, they tore them apart, and they measured everything. Size of the valve, size of the bore, subassembly, final assembly. They discovered Mazda never used more than 27% of total tolerance at any of those design scope levels. Do the math. That's a CPK greater than 3.7. That's greater than 11 sigma capability. Here we are in the 21st century. Patting our backs, have been talking about 6 sigma, settling for 4 sigma. The first Ford Escort transmissions Mazda ever made a generation ago came in greater than 11 sigma. Don't let people settle. The leader cannot let people settle. And the basic procedure for improving a system, any system, is illustrated here. This is the procedure cross-functional process improvement project teams go through to advance their progress step by step toward breakthrough process improvements. And along the side of the process flow, you can see the basic, intermediate, even some of the more advanced statistical methods, depending on scope of project, and where teams apply them to advance and accelerate their progress. And Dr. Deming noted these statistical methods are essential. A team cannot effectively, efficiently, economically make it through this procedure without the statistical methods. But Dr. Deming also added they're relatively unimportant. They're relatively unimportant, more important, leadership. And the third and fourth components of the system of profound knowledge, theory of knowledge, knowledge of psychology. And again, Deming noted, you'll see in his little paper, he talks about the individual components cannot be viewed in a vacuum. They interact with each other. He gives examples of how knowledge of variation is incomplete without knowledge and appreciation for a system. I've been fascinated over the years about the interaction between theory of knowledge and knowledge of psychology. Some of us who have done some graduate work in psychology, we have unleashed terrible forces of destruction. I think about it. Freud and the other determinists whose work was with the deranged. They were working with really deranged, whacked out people in the shadowy, candlelit, cocaine-fogged world of Freudian determinism. And yet, some apply their findings and methods to people with healthy minds. What price are we paying? The work of Pavlov, Skinner, Watson, Hersey, Blanchard, the other behavioral psychologists whose work was with animals. Their work was with animals. And yet we apply their findings and techniques to people. I sometimes ponder, how long will we continue to destroy our most important asset, our children, with grading practices, grading behavioral carrots and sticks that work with animals? This knowledge of psychology is more than just the psychology of change and dealing with that, but even more so, understanding and differentiating between intrinsic motivation that comes from within and the effects over time on intrinsic motivation of extrinsic motivators. Peter Senge, the author of The Fifth Discipline, once noted in one of his papers, the question, is it to motivate them or is it to loose their own motivation? He said, consider, for example, the goal of continuous improvement, which remains an elusive target for many organizations. Here's one approach: motivate them. From an extrinsic perspective, he wrote, the only way to get continuous improvement is to find ways to continually motivate people to improve. I mean, after all, Pavlov's dogs salivated. It must apply to your employees. Otherwise, Senge wrote, they will just sit there or worse yet, slide backwards. This leads to what workers perceive as management continually raising the bar to manipulate them. But here's another approach: loose their own motivation with information and appropriate tools. He wrote, however, from an intrinsic perspective, there's nothing mysterious at all about continuous improvement. If left to their own devices, people, I might add, not dogs, but people, will naturally look for ways to do things better. What they need is adequate information and appropriate tools. From the intrinsic perspective, people's innate curiosity and desire to experiment, if unleashed, I might add, if not blocked, creates an engine for improvement that can never be matched by external rewards. Throughout much of his career, Deming's principles came across as a top-down type of intervention. Top management, clean up your act and drive this thing. But toward the end of his life, Deming shifted gears on us. He said, no. The transformation begins with the individual. All else follows. The transformation begins with the individual. Senior leaders cannot jam these tools and concepts down the throats of their employees. All senior leaders can do is provide the opportunity to learn. They have to provide the opportunity to learn. From there, the transformation begins with the individual, all else follows. So we as individuals, not in teams, this is not a team activity, we've got to sit and ponder and study our own individual, personal, gut level value system as relates to this topic of motivation. Where do I fall on the spectrum of motivation? Do I fall toward the extrinsic end? People will not apply themselves to their work without some merit reward to pursue. Students will not apply themselves to their studies without some grade or honor roll status to pursue. Or do I fall toward the intrinsic end? People naturally want to contribute. People naturally want to experience pride and joy in the work they do. I can't answer that question for you. Deming couldn't answer that question for you. Your boss can't answer that question for you. We as individuals have to make that call. Where do I fall on the spectrum of motivation? As a management system, Deming's principles are heavily skewed toward the intrinsic end of the spectrum. Motivation is not an action verb. Motivation is not something I do to someone. Motivation comes from within. And all I can do is either set up or remove barriers to that intrinsic motivation. Deming's 14-point model, the healthy work environment that provides that healthy work environment free of barriers, but absent appreciation for a system, absent some knowledge of theory of variation, some of these points on their surface flat look goofy. I mean, look at point 11, eliminate numerical quotas for the workforce, eliminate numerical goals for management. Do we ever picture one of our customers saying, ship it whenever you're ready? Or do we picture the market imposing upon us ever more stringent, demanding deadlines and goals for delivery performance? What is he really talking about here? Are these the ramblings of a dead senile managerian? Well, he wasn't senile. He did have a tendency to overstate some of these points because he was trying to reach out and grab American management by the collar. He was trying to shake us up is trying to say, stop, American management. Think, 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 think. Think about your obsession with numerical goals and planning systems. Now, part of what he was asking us to consider is appreciation for a system. Sometimes the best thing an operations manager could do for the good of every employee, every customer, and every stakeholder in your company is not meet this month's shipping goals. Sometimes. That's the best thing he or she could do, because sometimes the best thing he or she could do for everyone in the system is to release some of their limited value-adding resources, their manufacturing engineers, to go work with the development engineers to improve the process at that last stage gate for transfer and scale up of new designs in production, so that those future transfers achieve higher and lasting first pass yields sooner. But in sending his or her people to go work with the development engineers, the operations manager doesn't have his or her people and doesn't meet this month's goals. And sometimes that's the best thing he or she could do for every employee, every customer, every stakeholder in your company sometimes. He was also challenging us to appreciate some knowledge of theory of variation. Here's the capability of your division for generating sales revenue. Management sets this goal for the next fiscal period. Is your current system capable of generating sales revenue at that level? No. So what Deming was saying was that numerical goal in and of itself helps no one. Only the method is important. Only the method is important. By what method might you change and improve the system such that it's capable of performing at a higher level? But he was also warning us, management, establish these numerical goals at your peril. At your peril, they could foster mediocrity. Here's the capability of your division for generating sales revenue. Management sets this goal for the coming fiscal period. Guess what? You need do nothing different. You need make no improvements at all. Random variation in the right direction, plotted from inaccurate, highly political sales reports, will be celebrated as a success. But you didn't do anything. You didn't change anything. And it will be determined to be good enough. Good enough. That's what he was encouraging us to do. Now, a lot of people have gotten themselves in trouble over the years trying to treat this 14-point model as a cafeteria plan. Yeah, point one, we got to improve products and services, no problem there. Point two, adopt a new philosophy. Yeah, those engineers better change their attitudes. They're really getting on my nerves. Point three, I know these inspection costs are killing us. We have too much dependence on inspection. Point four, end the practice of awarding business on the basis of price tag alone. One way Deming expanded on that was eliminate or reduce total cost by working with a single supplier. Oh man, we can't do that. They'll screw us on price. What if their plant burns down? What if they go on strike? Can't do that. Get rid of point four. Point five, we got to improve processes. No problem there. Point six, those operators need better training on the job. Point seven, those first line supervisors have to do a better job of leadership. Let's do more first line supervisor training. Point eight, drive out fear. There is no fear here. Besides, if there were, it's a motivator. Get rid of that one. Point nine, yeah, we got to break. I know we need teamwork. Point 10, I know slogans won't do it. Point 11, eliminate numerical goals. Point 12, eliminate the annual appraisal or merit rating system. Why? Those are the holes in my bowling ball. I can't picture bowling without them. I'm not about to let some dead man engineering come along and fill in the holes in my bowling ball. Get rid of those two. Point 13, yeah, point 14, got to do that too. And they set out trying to implement Deming surviving 10 points or so, completely missing the point that these are intricately interwoven in a complex fabric of a healthy work environment. This is also referred to quite often as the Deming philosophy. The 14 points are not the philosophy. The 14 points weren't even around until the 70s, when both Schirkenbach and a couple of people at Ford sat down. They wrote them down. They went back to Deming and said, is this what you're talking about? And Deming said, yeah. It's not the philosophy. That's not what he taught Mr. Toyota and the other Japanese executives. There were no 14 points. Well, if not these 14 points, how can we state the philosophy? Point two, the new philosophy for management involves learning and applying the system of profound knowledge. As we've been examining here, appreciation for a system, some knowledge of theory of variation, theory of knowledge, and psychology. I haven't addressed theory of knowledge yet because I was hoping I would run out of time, because this is the one that still drives me nuts. How can I have sound knowledge of theory of knowledge without some theory of knowledge on which to base my knowledge of theory of knowledge? And he's dead now. I can't ask him about it anymore. But you'll notice in that little paper, he tries to simplify it, noting that any plan, however simple, requires prediction. That prediction must be based on some theory. What's the theory? A statement devoid of prediction and explanation of past events conveys no knowledge. I'm going to go through this summary quickly, by the way. It is in that paper that you can, Deming's paper, you can download with the invitation to this webinar. There's no evidence, no theory without prediction and explanation of past events. There's no observation without theory. Interpretation of from test or experiment is prediction, but it is only in the state of statistical control that statistical theory aids prediction. Remember, the CPK, when you establish the CPK, you are predicting that I am only going to generate defectives at this level, or I am only going to use up this amount of the specification limit. But it only applies to stable processes. I was with a client over in France, and their quality director, Lean Six Sigma back then, he said, I always stress in our SBC seminar, you appeal for stable processes only. You've got to get the process into a state of statistical control before you start to compute or predict capability. He said, it does not matter. It does not matter. He said, if your CPK is high enough, it doesn't matter if the process is stable. You won't produce any defective parts. And I said, no, but you calculate the CPK based on the assumption of stability. No, it does not matter. It does not matter. So at the end of that day's session, I wandered back to a test lab, I'll say, and I was talking to test technicians. What are you doing? Well, we're testing batches or sample batches for pH. And this is how the quality director told us to do it. And because they had just completed a Six Sigma process improvement project and publicized a CPK of 2.5. So I said, oh, that's interesting. How are you doing it? So they gave me some of the data sets. I took it back to the hotel room because if a soccer game's not on French television, it's horrible. And I just, constructed control charts. Boing. They're the XBAR charts for the batch pH readings. Chaos. Now, what will your statistical software do? Well, the lower spec limit was 7.1 pH. Okay, what's the CPK? Well, CPK versus lower spec, I'm going to subtract 7.1 from the grand average and divide by 3 standard deviations. Then the software for your grand average will pluck the central line off your XBAR chart, in this case, completely ignoring it was in a state of chaos. By estimate of the standard deviation, I'll pluck the central line off the R chart, R bar average range, completely ignoring the R chart was in a state of chaos. Divide from lowercase d sub 2 from Shewhart's table of factors depending on subgroup size, and I get the standard deviation. I then plug and chug those values, and sure enough, the CPK comes out to 2.5. Now, what does the CPK of 2.5 mean? That means I have 7.5 standard deviations between my average and that lower spec limit. That means I have 4.5 standard deviations between my lower process limit and the spec limit. How can that be when 11 of the individual pH readings fell at 7.1? How can that be? And I presented this the next morning. I said, I suppose it does matter. And when we were flying home, the corporate quality guy who was there traveling with me, he said, Jim, I almost fell out of my chair when you showed those slides on the CPK at 2.5. He said, we've been beating up other divisions. We said, hey, French division's at 2.5. What's wrong with you? He said, worse yet, we have publicized this to some of our customers. And he said, it's going to be really embarrassing to go back to them and say, well, no, not really. And I said, it's going to be a lot more embarrassing when you put a customer in a line down situation with a defective batch of product they thought was coming from a supplier with a CPK of 2.5. So the following week, I went back into corporate. We met some of the corporate quality and corporate marketing people. Gee, how are we going to deal with this? And they decided to take the high road. They just went back to the customers. We're told about this 2.5. There was an error in the calculation, but we nonetheless assure you, we will continue to apply statistical method to achieve continuous improvement in product and service that we deliver to you. It does matter. Experience is no aid in management unless studied with the aid of theory. Experience without theory teaches nothing. To copy an example of success, examples without theory teach nothing. I mean, Deming's point 12, eliminate the annual appraisal or merit rating system. That's so radical. When I restated the 14 points as obligations for the school board administration, Dr. Deming insisted that the restated point 12 read in part abolish the grading system for America's schools K through 12 and higher education. That's so radical. How do I know how my kids are doing in school without grades? How do my children get into college without grades? The proposal that we abolish is so radical. So it's not unusual for HR people or educators to come to me and say, okay, Deming says all of this appraisal and grading is wrong. Give us an alternative to the grading system. And I'm slower than most, but I've learned over the years that the best response to that request is to answer with a question. I ask them, if I give you an example of an alternative to your appraisal or grading system, do you promise me you'll implement it? They say, heck no, sight unseen, you kidding me? I said, okay, if I give an alternative to your grading system, what will you do with it? Well, we'll evaluate it. You'll evaluate it relative to the current system. I'm slower than most. I realized over the years I was doing those people a disservice, handing out examples of alternatives, traditional performance appraisal or grading like candy. I don't want them to compare the alternative to what they're doing now. I want them to compare the alternative and what they're doing now to a rational theory. Let's talk about the theory. That's why with our executive workshop, it begins and it's all built around Deming's classic bead experiment that teaches the theory. So the question is not, are these employee performance levels different? They're going to be different. The question is not, are these student achievement levels different? They're going to be different. The questions are they significantly different? If those performance or achievement levels are significantly different, treat and reward them differently. Nobody ever said everybody gets the same raise. Nobody ever said all students get the same grade. On the other hand, if those performance or achievement levels are not significantly different, don't treat or reward them differently, because the limits we use to test for significance are dictated and controlled by common causes of variation from within the process or system of which those people are but a part. And people can perform no better than the process allows. When you really think about it, what's so radical about a proposal? To stop appraising people and start leading people. What's so radical about a proposal to stop grading students and start, I don't know, how about teaching them? See if I can see. Oh, I messed up. So, an example without understanding with data theory could really lead to chaos. No number of examples will teach a theory. No number of case studies will teach a theory. I think about my graduate business school experience. What do they teach? Case studies. Out the yin yang. They failed to meet their obligation in exchange for my hard-earned GI Bill. They provided skills. They did not provide knowledge. There's no true value of any characteristic, state, or condition defined in terms of measurement. Come up with a more precise measurement instrument, you'll get a different measurement. Communication requires operational definitions. What do we really mean by on-time delivery? Is that clearly defined and understood? And there's no such thing as a fact concerning an empirical application. This is, all the stories about 3 witnesses observed exactly the same holdup at the bank. They give completely different descriptions of what the robber looked like. So that's, again, these are provided in your paper to review and ponder. But the new philosophy, again, it's not the 14 points. It involves learning and applying the system of profound knowledge in order to understand the statistical nature of work. The question is not, are these outcomes different? The questions, are they significantly different? Then view work as a dynamic process. Then take appropriate action to accomplish improvement, because in this new economic age, there is and can be no such thing as good enough here. That's the philosophy. That's what he taught Mr. Toyota. That's what he taught all those people before the 14 points even existed. So when we view these 14 points in the context of the philosophy, what is it we're looking at here? For the most part, we're looking at a listing of common American management beliefs, myths, and practices that act as barriers. Barriers to our being able to implement, barriers to all employees, customers, and stakeholders being able to benefit from the philosophy. For example, if we're not willing to question our obsession, if our numerical goals have the unintended effect of defining good enough in people's minds and their subsequent behavior, that will forever be a barrier to people trying to accomplish improvement. If that, well, it's good enough. If it ain't broke, don't fix it. That will be a barrier. If we're not willing to question our obsession, point 12, with grading and ranking and evaluating people, that will forever be a barrier to people's being able to understand the statistical nature of work. The question is not, are these employee performance levels different? The question is, are they significantly different? And it will forever remain a barrier to people's being able to view and understand work as a dynamic process. And person equals output is not the process model. Attributes of a leader, as Deming taught them. Point 7, let's look at the hard part. Institute leadership. The leader understands how the work of his or her group fits into the overall aims of the organization. The leader focuses on the customer, both internal and external, and won't let anything get in the way of that. The leader is coach, counsel, and teacher, not a judge. The leader removes obstacles to joy and work. The leader understands variation. The leader uses systems thinking, statistical calculation, if not on his or her own, with the help of an internal resource person, to discover who, if anyone, is outside the system in need of special help. We provide the special help. If after providing the special help, that person cannot move into this group that constitutes the system, we must find a less demanding or more appropriate placement for that person. But because of this understanding of variation, the leader understands these people who constitute a system must not be ranked. Therefore, because of this understanding, the leader works to improve the system in which he or she and their people work. Please note, improve the system, not rank people, not grade people, not appraise people, improve the system. The leader creates trust. The leader forgives a mistake. The leader listens and learns. The way all the 14-point model is intricately interwoven is most obvious here. We're trying to look at Deming's point 7 in a vacuum. Institute leadership, we cannot talk about Deming's point 7 without having made reference to Deming's point 1, create constancy of purpose. Deming's point 5, constantly and forever improve every process. Deming's point 8, drive out fear. Deming's point 9, eliminate barriers between department and work groups that through optimization all might perform at higher levels. Deming's point 12, stop measuring and ranking people, start coaching and helping people. Deming's point 10, 11, and 12 as they interact. This understanding of variation. Deming's point 13, adopt a vigorous program of education and self-improvement for everyone. A copy of this slide is provided in your handout, but here we are trying to wrap up, talking about one of Deming's 14 points in a vacuum, point 7. We cannot talk about point 7 without at the same time making reference to 10 of the remaining 13 points, because they're intimately interwoven. And you would expect this level of complexity if our topic here has been the hard part, leadership. And there is no substitute for knowledge to guide the leader's decision, actions, and plans. Thank you for taking the time to sit in on this webinar. I'll turn it back over to Angelo as our moderator. Questions, comments, curses.
Great. Thank you very much, Jim. Thank you for the excellent presentation. I think many of us in the quality management systems, quality systems, or process improvement involvement over the years have learned to appreciate Dr. Deming for his principles. And there was an excellent run through of the leadership principles according to the 14 points. One of my favorite, personal favorite comments that he made over the years was as follows. One conference I was at, he said that the aim of leadership should be to improve the performance of man and machine, to improve quality, to increase output, and simultaneously to bring pride to the workmanship to people. And to put it in a negative way, the aim of leadership is not merely to find and record failures, but to remove the causes of failure to help people do a better job with less effort. So let's see, couple of questions, Jim. I think a couple of questions were concerning the 14 points, how they integrate into the leadership principles. And from what I've seen, you've done a pretty good job at that. Those questions came in a little earlier in the presentation. Mm-hmm. But if you wanted to expand on that a little bit, it's fine.
Well, I don't know. If that came in earlier before I went through the 14 points, then it's just,
Right.
I think the main thing the leader has to bear in mind, you can't take Deming literally. He wasn't a literal guy. And take, for example, point 12, eliminate numerical goals for management. But one way he expanded on it, so you can't stop at this webinar, you can't stop at our little handout. Really what I was trying to do here is to put people who attend this webinar in a position to make a decision. Do I want to learn more about this or not? If yes, get your hands on Out of the Crisis or the New Economics for Business, Education, Government, and do additional self-study. Because one way he expanded on those on that point 11, eliminate numerical goals for management, ... unless methods are provided to help reach the goals.
Right.
It doesn't mean we're not going to establish certain targets, but we must provide the methods to meet those goals. Otherwise, the numerical goal in and of itself it helps no one.
Excellent.
So I think that's the main thing, is that I would just encourage, as it relates to any of the individual 14 points or as a whole, I just urge you further self-study. Or come to one of our transformational leadership seminars. We'll take you not only through that, but all the way to the point of a 6-page Gantt chart where you start to draft your implementation plan for process and organization excellence. So those are a couple of suggestions there for the 14 points.
Great. Thank you very much. And I know this question is going to catch you off guard a little bit, and I apologize for that. But the question is, under the current crisis that we're going through with COVID-19, does anything come to mind in terms of how these leadership principles may apply at this time to assure that, we progress the right way, and once we get out of this crisis, the organizations can be as effective as possible?
Yeah, this is a question that could result in some offensive comments by me or others. But think, for example, there are a lot of reports about a lot of the things we've done, including the virtual shutdown of our economy, are based on certain models. Many of them haven't even come close to being accurate. So you that's certainly how it would apply to this crisis that's going on. It's a lot of it related to theory of knowledge that, come up with a different way of measuring something, you get a completely different outcome. So some experts are being guided by one model, some by another, and there's conflict with that. But, in terms of coming out of it, just good, solid process thinking of saying, the Pareto principle is a universal principle. What do I have to do first? Because I can't bring everything up to 100% capacity right out of the chute. And if I try that as a leader, people are going to choke to death. So again, just being guided by, let's just apply a little Pareto thinking here. I can't do, what are the vital few first steps? One of our clients, I guess I shouldn't name him, but I've been exchanging some correspondence with them. Their leadership team is just doing an absolutely outstanding job of, keeping some of their medical device manufacturing going on, but making sure there's good social distance, making sure changes to scheduling. My little brother works for a company where they were told by the state of New York, you can only have 50% of your people. There's too many people. Well, they didn't have a night shift, so guess what? They have a day shift now, and they have a night shift, and everybody's still working. So, those types of things and thoughts are certainly applicable.
Very good. Okay, right now I'm going to just turn it over to Chris for a second. He's got some information on some of our upcoming webinars, a couple of them of yours, and a couple of other information points. Go ahead, Chris.
Yes, hi. I would like to thank you for attending the webinar. I'll be sending out an email tomorrow or early next week with a certificate of completion for this webinar. Jim has a webinar next week, April 28th on DOE. Why does it have to be so complicated? On May 1st, if you work in Massachusetts or your company's in Massachusetts, we have a Massachusetts grant informational session on May 1st. On May 4th, Laura Halleck is teaching an FMEA webinar. And on May 6th, Bob Deischer is teaching an ISO 14971 webinar. And as always, you can find our webinars on the website, and I will send you an email tomorrow or early next week with a completion for this webinar. And thank you again for attending, Jim. Great job.
Okay, thanks, Chris. Thank you, everyone.
Thank you, everyone. Have a great day. Looking forward to having you participate in another webinar. Appreciate it.